Hello guys. Given a trig function, you should be able to graph any equation, such as sine, cosine, tangent, cosecant, secant, or cotangent. What we're going to do today is start from the graph of a trig function, and our goal is to write two different equations. If, for instance, I have a function that looks like the one I have on number one, I should be able to write two different functions, one being sine, one being cosine. In order to write those two equations, the first thing to do is identify a good point. Now, I can pick this point here, and if I pick that point, that'll be a cosine, and the fact that I'm starting up is a positive cosine. Or I can pick this point here, and if I pick this point down here, that'll be a cosine, but because it's down, it's going to be a negative cosine. I can also pick this green point, and that will give me a sign. And after the middle point, if I go down, that means it's a negative sign, or this will be my positive sign. Let's go ahead and start with this -4 that I have here. Now, the fact that I know is that -4, I know already that it shifted -4 units to the, I should say, -4 units to the left. Now, but before the shift -4 units to the left, I look first for my dotted line. Here, I know it looks like you have too many dotted lines, but we're looking at the middle line. The middle line is 5 units down, so I will start my equation with y equals -5. -5 because my dotted line is at 5 units down. From here, I will know that if I'm using this point, I will have to use the plus sign because it's high up there. I don't know my amplitude, but I can calculate it. It's just the distance between -5 and 2 or between -5 and 12. One way of doing it is to do 2 minus -5. You will get 7. So it's 7. My amplitude is actually equal to -5 minus -12, which is equal to 7. So I have 7 here, and I know that I'm using a cosine as a trig function. For now, I don't know the value of b because b will go here. And inside the parenthesis, because I'm dealing with theta, I will put theta. Note that theta is in degrees. And we say that we will be moving 4 units to the left, so I will need to put plus 4 here. Now, while in here, I need to figure out b. To find b, all I need is, because I'm dealing with radian, is 360 over the period. So let's go ahead and find the period. The period is from top to top. So from this point, the period will be from this point all the way till this point. And to find that distance, all I need to do is I will take this 8 and find the distance between 8 and -4, or you will do 8 minus -4 and you should get 12. And if you do 360 divided by 12, I believe you get 30. And from here, you just need to put 30 here because that's your b. And that's an equation using cosine. If you wanted to use sine, meaning using the green button, let's go ahead and pick one. I want to pick, why not a positive sign? The reason I'm picking this is because I can easily calculate it. This cross that I have, the green one, is the middle between 8 and 2. To find that middle between 8 and 2, all you have to do is find 8 plus 2, that will be 10, divided by 2, that will be 5. So I'm 100% sure that this point here seems to be at 5. Now that I know that this point is at 5, it seems that everything shifted 5 units to the right. So inside my parenthesis, I will have theta minus 5. And that is the only thing that will change. Everything else will be the same. Of course, the trig function will change and the sign will change because now we're starting in the middle and it's positive, so it's actually plus also, and it's still 7, and here we have the sign. Don't forget to write y equal. Let's go ahead and look at problem number 2. For problem number 2, it looks like I will have either sine or cosine again. Just like number 3, I will have either sine or cosine. Let's go ahead and pick a good point. I'll pick this point, and if I pick this point, I'm dealing with cosine. So for the cosine, I will have y equal. The fact that the dotted line is at 5, I will start with 5. And because I'm starting up, I will need to put plus My amplitude is the distance between 5 and the highest point, which is at 7. So my amplitude is 2. We're working with cosine here. I will need to find my b. B is actually, I need to first find the period, which is from top to top, and that period is from pi to 7 pi over 6. And if you're trying to find the distance from pi to 7 pi over 6, you travel 6 pi over 6, which is actually pi. Now, to find your b, you will say 2 pi over b, b being pi. So apparently, the period, 2 pi over the period. The period is pi, 2 pi over pi is 2. So here I will have 2. And inside the parenthesis, because I'm dealing with x, I will say x. And I need to find out what was my horizontal shift. And the horizontal shift here is pi over 6. So I will put minus pi over 6 because it moved pi over 6 to the right. Let's do the same thing now for cosine. Or for sine, I mean. Now, you get to pick. You can pick this point and use it as the negative sign, or you can pick this point and use it as positive sign. So it's up to you. I have two different points that I can use. Let's go ahead and use the, why not the, I want to use the positive one. Note that to find this, all you got to find is the middle between these two. And you got it. So I'll go ahead and find the negative one. Now, this is pi over 6. This is 2 pi over 3. You can convert this one into, you can say 4 pi over 6, if that makes it easier. 4 pi over 6. Now that is 4 pi over 6 and pi over 6, the distance in between these two is actually the middle point, which is this here, would actually be 4 plus 1, which is 5, divided by 2, 2.5 pi over 6. But you do not write 2.5 pi over 6. Instead, I will write 5 pi over 12. Keep this in mind. If you do not understand how to get this, you need to raise it up in class, and I'll go over it. Now, I will have, therefore, y is equal to, the 5 will remain the same. Instead of plus, because it's a sign going down, I will have a negative 2. It's still a sign. B remain the same, but inside the parenthesis, I will have x minus 5 pi over 12. I will go a little faster on this one. Let's start with the highest point. The highest point, here you can count. And if you count correctly, you should get 9. And the lowest point seems to be at negative 1. The middle between 9 and negative 1 is actually 4. 1, 2, 3, 4. And this is where you actually have your dotted line at 4. So I will label this one as 4. So my equation is already y equals 4. Because it shifted up. Whether it's sine or cosine, it should start with y equals 4. Now let's go ahead and pick this point, why not? And if we pick this point here, it seems to be at 1. And if I pick that point, of course, I'm dealing with cosine. The distance between 4 and 9 is 5. So amplitude here is 5. Let's find the period so that we study the whole equation before we start writing. The period is from 1 all the way till, if you count here, you should get, here is apparently 13. This is 13. This is 1. So this distance, which is my period, is therefore 12. Now, period being 12, this is therefore equal to 2 pi over 12. I'm using radians here, so make sure you write this is in terms of x. So you can put an x here. So I say 2 pi over 12, and if you divide 2 pi by 12, you get pi over 6. Now, the first equation would be y equals 4 plus 5, because my amplitude is 5, cosine of pi over 6, in parentheses, x minus 1. That's in case you want cosine. And if you want sine, I can look here. It seems like this point here, I'll mark it in red, seems to be at negative 2. So I will have y is equal to 4. Because it's a sign going up, I'll put plus 5 sine. B remain the same, pi over 6. But inside the parentheses, I will have x plus 2. Because this one seems to shift, it was shifted 2 units to the left. All right, I'll look at this one. This is by far, I believe, one of the most complicated one because the axis is not labeled. But I do know that this is at 0. The fact that that's at 0, it makes it easy for my cosine function. Let's start with the amp though. The amplitude here is, if you calculate it correctly, is the distance between 4 and 13, and you should get about 9. What else should we look for? Let's find the period. Why not? The period here, we should know that is from this point to this point. So that's 1 times the period, 2 times the period, 3 times the period. This is 1 period. This is 2 periods, 3 periods, 4 periods. So 4 times the period is equal to pi. So the period itself is pi over 4. How do I know? From 0 to pi, it seems like I'm counting 1, 2, 3, 4 periods because I have 4 times the distance from one peak to the other. So apparently 4 times the period is equal to pi. So the period itself is pi over 4. Now that I know that the period is pi over 4, the critical point is therefore pi over 16 because I do the period divided by 4. Since the critical point is pi over 16, I can now label that this point here will be at pi over 16, this point will be at pi over 16, pi over 16, and so on. Let's go ahead and write the equation using, or before we write the equation, I will do 2 pi here over b, meaning over pi over 4. And if I do my copy change flip, I get 8. So my b is 8. So the equation would be y equals, let's start with, why not cosine? Because that was the easiest point. And I'm picking this point on the axis. So y is equal to 4 plus 9 cosine of, I can just say 8x because there's no shift at all. It starts right there on the axis. For the sine, instead, it will be y equals, the same 4 will remain. Instead of plus, let's pick this point. This point seems easy. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, if you count. Here's the first one, second, third. So it's 4 plus 9 sine of 8 remain the same, and here you have x minus 3 pi over 6. Although it says write 2, I will write one more. That can be y equal 4. I want a negative sign, minus the negative sign will be the first pi over 6. So I will have 9 sine of 8x minus pi over 6. In other words, there are multiple ways of writing equation for each one of these. Let's look at the next one. This time, it seems like the highest point is at 3 and the other highest point is at 23. So obviously, my period is equal to 20. Now that I know my period is equal to 20, b is therefore equals to, because we're dealing with theta, I will say 360 divided by 20. And if you divide 360 by 20, you get 18. Now that we have our b, it's of course easy to find the equation using cosine because we have the highest points here. Why don't we look for also these points? To find these points, I need to know the critical point. It seems like the critical point would be period. CP is always period over 4, meaning 20 divided by 4 is apparently 5. So since it's 5, this point is 8, this middle point is 16, and this point here is, 8 plus 5, I just say 16, but it's 13. And this one will also be 18. Now we can write the equation. Let's start again with cosines. That's y equal, the dotted line, I forgot to mention. This dotted line is the middle distance between these two. So if I do 56 minus negative 38 and I divide it by 2, I will get, if I add these two and I divide by 2, I should get 18 divided by 2, it should be 9. So this is at 9 units above. So it's y equals 9 plus 47. The reason I'm adding 47 is because the distance between 9 and negative 38 is 47. And now we have a cosine of 18 inside the parentheses. Since we're dealing with cosine, I'm going to pick this point, and I will say is theta minus 3. Now, if I was doing sine, I will have y is equal to, for sine, I will pick, why not the first point? I'll pick the first point. If I pick the first point, note that is middle going down. So I will have 9 minus, because it's going down, and I will have 47. And it will be this time sine of 18. Inside the parenthesis, I will have theta minus 8. Two more graphs and we'll be done. The last two graphs, the first one looks like a secant or cosecant. So the two equations, one will be secant, the other one will be cosecant. Note that secant is cosine related. So I can pick this point for secant. I do apologize for this, but it seems like my dotted line have shifted. So instead of being here, it's supposed to be somewhere here. So this dotted line is wrong. It's supposed to be here instead. Now, because it was wrong, I will avoid using this point. I will pick better points. So for cosine, it doesn't matter. I can still pick this point because I know that the point is at pi over 2. Now, let's go ahead and find the period. The period is from this first blue dot to this other blue dot, from pi over 2 to pi. So if you find that distance, you will notice that the distance is actually pi over 2. So this one is pi over 2 away. That's my period. Now that you want to find the critical point, you will do 2 pi, not the critical point, but B is equal to 2 pi over pi over 2. And if you do 2 pi over 2, you should get 4. Now that I got B, I can also figure out that I can use this point for sine, but let's write the equation in terms of secant first. Y is equal to 1.7 seems to be my vertical shift. If you want, you can graph a dotted line there, but I know it's at 1.7. Because I'm starting above there, I'll put plus. The distance between 1.7 and 4.2, or this distance, is actually 2.5, I believe. 4.2, yes, it's at 2.5. So it's 1.7 plus 2.5. I'm using plus because I'm picking a point above, and I will write secant, because we're dealing with cosine here, because it's secant here, and my B is 4, and inside the parenthesis I will have, let's change this one into x instead of theta, and change this one into theta. Why not? So that will be x, and this point is pi over 2, so minus pi over 2. Let's do one also for sine. For sine, because this point was kind of messed up, so I will use this point instead. So I will say y equals the 1.7 remain the same, 2.5 remain the same. This time is cosecant because it's sine related, 4, and inside parenthesis I will have x, and this is at 7 pi over 8 minus 7 pi over 8. And that will be your second equation. Now, for the last one, it seems like it's a tangent graph. And there are two things you can do. You can also make it, although it's increasing, if you reflect a cotangent, you actually get a tangent graph as well. But let's go ahead and start with tangent. If I want to use it as tangent, I first need to know what this middle point is, because that's my dotted line, or this point. So I'll pick this point here, the closest to the axis, to make it easier for me. It's at -2. Now, the distance from this point to this point, meaning this distance, should be my amplitude, and this is -2. This seems to be at 3. So from -2 to 3, I think the distance is 5, and that's my amplitude. Now that I have my amplitude, I also need to know the period. The period is between -20 and -8, or -8 to 4. And if you calculate it right, you should get that the period is about 12. So this distance is 12. Now that I know it's 12, I will say B is equal to, remember, we're talking about radians here because I put theta, or we can do, actually theta is in degrees. Let's use degrees here, but because it's tangent, I will just use 180 over 12. And if you do 180 over 12, I believe you get 15. So the equation would be y equals, our shift is at -2. After -2, I'll put plus, my amp is 5, and I will use the tangent of 15, and inside my parenthesis I can pick this point or this point, but I'm gonna pick x plus 2 equal being x plus 14. Now this is what I was mentioning earlier. I can also say is y equals -2, and I use the tangent and or the cotangent. But if I'm dealing with cotangent, I need to use the dotted line. Let me show you how it can be a negative, how it can be done with a cotangent. It's at -8. You will no longer use this point, but your focus should be on this dotted line instead. Or this dotted line, you pick. I can make it this dotted line also. Note that this one was at 4. My dotted line just erased the 4. So this is at 4, and this is at -8. So if I want to use cotangent, I would say it's -2. Cotangent, I can still say plus. 5 will remain the same. Cotangent of my period remains the same, 15, but inside my parentheses I will have x plus 8, or I can also have x minus 4, either or.